Okay, here we go. Let's get through this quickly. All right, so we gotta establish first of all, what is the least common denominator? Close up, all Chromebooks need to be closed, please. So our denominators are, I've got a 1 on the bottom here, I've got an x there and an x squared there. So what's it gonna be? X squared, right? Because I gotta pick the smallest expression that includes the factor 1, x, and x squared. Well, that's x squared, right? Okay. So our LCD is x squared. So I'm just going to multiply an x squared through by both sides, right? To clear the fractions. That's what we do, right? So if I multiply that through, if I distribute it, what am I going to get? Okay, when I distribute the x squared to the 1, I just get an x squared. When I distribute the x squared to the 12, I get 12x squared over x. Well, what's x squared over x?
12x.
X, good. So plus 12x, and then over here they just cancel, right? So I just get negative 32. If I put that in standard form, right, we're going to solve a quadratic equation. We set it equal to 0. And so what are my magic numbers going to be?
I don't know.
Yeah, you do.
8 and 4.
Oh, hang on here.
Right?
Yeah,
8 and 4.
but they have to multiply to 32 and add to, 8 and 4, you're right. Never mind. I was looking at that as 2. You're right. Good. So what are my solutions then? X equals,
Cool. Easy peasy.
okay, and then what would we do? See if we got it right.
Check it.
Okay, let's just do that once. If I plug those in, let's plug in negative 8. What's that going to give me? I'm going to get 1. What's 12 over negative 8? 12 over 8 reduces to what? Well, I'll just write this step out. So we get 1 plus 12 over negative 8. Does that equal
3 over 2.
negative 32 over negative 8 over negative 8 squared? So that's going to give us, yeah, it's negative 3 over 2, isn't it? Positive over negative is negative. So 1 minus 3 halves, is that equal to negative 32? What's negative 8 squared?
64.
Positive 64. Okay, so now 1 minus 3 halves is what?
1/2.
Positive or negative?
Positive.
Negative, right? Because if I get a common denominator, that's just 2 halves minus 3 halves is negative 1/2, right? So we get negative 1/2. Is that equal to, yeah, that's negative 1/2, so it checks, right? See what I'm saying? So we could just check them that way, couldn't we? If we plugged in the negative 4, what would we get? We would get 1 plus, what's 12 over negative 4? Negative 3, right? So 1 minus 3 is negative 2 on this side. What about over here? I get negative 32 over negative 4 squared is just positive 16, right? Negative 32 over positive 16 is negative 2, so that one checks also, right? So we should check all those things if you're ever on a high stakes test where you can't retake it, or you can't retake it many times. Okay, so we got it. Solve the proportion. Well, same thing, right? What are we going to multiply both sides by here? What's the LCD here? 2x, right? So to get 2x, what am I going to multiply top and bottom by here? 2. Right, now I've got a 2x on the bottom, and then this is just 1 over 1. So I just multiply by 2x over 2x, right? What's that give us? This fraction becomes 10 over 2x equals 6 over 2x plus 2x over 2x. So I get a common denominator of, what am I doing here?
I don't know.
What am I doing here? I didn't mean to do it that way. I was thinking this was an adding problem, sorry. I mean, this would work, but if we're if we are, if we're just solving an equation, we don't even have to get a common denominator, we just have to multiply by the common denominator, right? Sorry, my mistake. Let's go back. So the LCD, you already told me, is 2x, so I'll just distribute a 2x through both sides. It makes it easy, right? So over here, the x's cancel, and I just get 10. If I distribute it through here, the 2x's cancel, right? And I just get a 6 plus 2x. Everybody agree?
Yep.
Okay. Subtract 6 from both sides. 4 equals 2x, so what's x? 2. Plug it in and check it, and it works, if you do.
Are you always gonna get 2 X's or just one?
Well, no, in this case, you just get 1. It's okay to just get 1.
Okay.
Right, and the reason we just get 1 is when we clear the fractions, we got an equation, a linear equation. It's only got next to the 1. If it was x squared, then we would have maybe gotten 2, right? How do we know, what's the one value of x that we couldn't have in this problem? What do you think? 0, because I can't divide by 0. So 0, if x equals 0, those fractions would have a 0 on the bottom. X cannot equal 0, but that's okay. Our solution's not 0, so it's still a good solution. Right? Okay, solve the proportion. Same thing. There's a little trick here, though, I just want to remind you about. The common denominator would just be x plus 6 times x minus 12, right? Well, if I'm going to get a common denominator, I would multiply this side through by the whole thing, and the x plus 6's would cancel, right? Everybody see that? If I were to multiply this side by the common denominator, x plus 6 times x minus 12, and this side also, look what happens. The x plus 6's cancel, and the x minus 12's cancel. So I just end up with the equation x minus 12 times 2 equals 6 times x plus 6, right? Well, you learned that trick when you have a proportion, which just means you have a fraction equal to a fraction. What do you do? What did you learn to do in Algebra 1 to get rid of the fraction? Cross multiply. Isn't that just really all you have to do here? Right? If I cross multiply, I get 2 times x minus 12 equals 6 times x plus 6, right? Oops, I need to do that. That in parentheses. Okay? And then I just solve, right? Distribute, isolate x. Okay, no big deal. Right, so if you get a fraction equals a fraction, there's no other. This one, I changed the wording on this. This isn't a proportion because this side isn't just a single fraction. So the wording is now changed on that one. When you take the final or the practice final, it'll show up differently. This one, you couldn't do that on. You had to clear the fractions. But this one is a proportion because it's just one fraction equals one fraction. So just cross multiply and solve. Okay, solve the rational equation. We're just going to multiply both sides through by the LCD, right? So what is our LCD here? If I got to factor these first, right? So I end up with x minus 1 over x minus 5. These are already factored, these first two fractions. Oops. What does this bottom quadratic expression factor into? Good. X minus 5 times x minus 6. So you agree that the LCD is just x minus 5 times x minus 6, right? So if I multiply both sides through by that, what am I going to get? Okay, so what do we get? If I distribute that LCD through both sides, right? I'm just gonna get here, I'm gonna multiply by my x minus 5 times x minus 1, and what cancels? The x minus 5s, yeah. Okay, so those guys go away. If I multiply through here by x minus, oops, why did I pick a 1? I don't know why I multiplied by 1, that should have been a 6, right? The x minus 6's cancel, right? And then over here, everything cancels, right? And so we end up with, if we do that, we just end up with x minus 1 times x minus 6 equals, just that stuff survives, negative 7 times x minus 5 minus 4 times, just minus 4. Everything canceled there, right? And I'm just going to solve that equation. Okay, but before we go any further, look at what our least common denominator was. What values of x have to be excluded? What's our domain? These were the factors that were in the bottom, right? So what values of x have to be excluded? 5 and 6, right? So x cannot equal 5, x cannot equal 6. So they just want us to list the x values here that are excluded, so I would put a 5 and a 6 in blue, right? Okay. The solutions are what? Well, we got to finish that. If I FOIL this out, I'm just going to get x squared minus 7x plus 6 if I distribute the x and distribute the negative 1 and combine like terms. And you would get the same thing. Just if either you see that right away, or if you don't, just trust me on that. You would get the same thing. I just want to go fast through this. That's going to give me negative 7x plus 35 minus 4. So now I'll just push everything over, keep the x squared positive, so I'll add 7x to both sides. Well, look, those cancel, right? And then I get 6 here. 35 minus 4 is, what is that, 31, right? So if I subtract 31 from both sides, I get x squared minus 25 equals 0. Well, actually, I could just isolate the x, couldn't I? I could factor that, or because I have a single x, I can isolate it. So let's leave the 25 over there. If x squared equals 25, what do I do to solve for x? Square root. So what's my answer, or answers? Plus or minus 5. Okay, let's look up here. What are our excluded values? Positive 5 is excluded though. So what's the only one I can keep? Yeah, so we only get to keep x equals negative 5. Right, because the positive one was excluded. So that was not a valid solution, right? Okay, that's kind of a harder one, I think, but you guys have done stuff like that. Okay, what about this? There's a good little trick for this. It's not a big deal. If we want to simplify a radical like this, remember, what we're going to try to get out of this is we just want to get as much out of the radical as possible. So we get some stuff outside the radical times some stuff inside the radical, right? Well, let's deal with the number part first. So I've got the square root of 20. What is that split up into if we break it into an integer part and a radical part? What do we get? I mean, what is the square root of 20? What's that say? What's the biggest perfect square factor of 20? 4. So we break that up into square root of 4, put a circle around it, times the square root of 5. And what's the square root of 4 become? 2. Yeah, so 2 radical 5. So then we get a 2 outside and a 5 inside for the number part. Okay, that's the hardest part, honestly. Now let's look at the variable part. So I've got a square root of x to the 5th. Okay, so if I want to write that as a fractional power, what number goes on the top of the fraction? Before you answer that, what number sits on the radical? What's the index if it's a square root? Okay, 2. We don't write it, but there is a 2 there, right? So which one goes on the top and which one goes on the bottom? 5's on the top, 2's on the bottom. So that would be x to the 5 halves. Remember this trick. All you got to do, if I want to simplify that radical then, is turn that fraction into a mixed number. Tyler, what is 5 halves as a mixed number? 2 goes into 5 how many times evenly? Oh, there you go, good. 2 and 1/2, perfect. So then the 2 goes outside, right? That's the part the integer part is what's outside the fraction, and the fractional part goes inside. So technically that's an x to the 1/2. Now we wouldn't write the 1 or the 2 though, right? So in Moodle we would just write our answer like this: 2x squared times the square root of 5x, right? See how that works? Because you had a 1/2 left over, there's your 1/2, x to the 1/2. Okay? This one is really similar. We would want to, first of all, if we're trying to simplify the square root of a fraction, we want to see if we can reduce the fraction. If we can, but we can't. Like if that were a 5 on the bottom, 20 over 5 would just make that a 4 on top, and that would make life a lot easier. But it doesn't work out that way this time. So we just split this into separate square roots. We've got the square root of the top over the square root of the bottom. And we'll just simplify them both as far as we can. And then we have to clear the stranded radical if we have one on the bottom. That's our strategy, right? So what about the top? This is very similar to the last one we did, right? We're going to end up with, on the top, we're going to get a part that's out front of the radical and a part that's in the radical. But what's the 20 going to do? We just did that one. 20 breaks up into the square root of 4, which is 2, times the square root of 5, which is stuck inside, right? Okay, but what about the part that's a little different that I want you to think about now is this part. We get an x to the 7 halves, right? Okay, so we got to turn that into a mixed number. So what's that going to be as a mixed number? 7 halves. 3.5, right? Good, so we get x to the 3 1/2. So what power of x gets out of the radical? What's it going to be, Riley? Which part? If I can turn x to the 7 halves into x to the 3.5, what's the power of x that's outside? 3, good. And what's the power that's inside? Right, so and that just means my 1 is there and there's my 2, right? Okay, so that's how we would leave the top. On the bottom, there's nothing I can do, right? The bottom, 7 stuck in there and I've only got a y to the 1. Well, y to the 1/2 as a fraction is just y to the 1/2, right? We don't get any part of that one outside. Right? You ever see that? If I have y to the 1/2, well that's y to the, there is no mixed number, it's a proper fraction. So there is no integer part, so none of it makes it out. What do I do though? What's my simple rule? If I'm stuck with a stranded square root on the bottom, how do I get rid of it? Multiply top and bottom by what? How do I do that? By the square root, don't I? Whatever the stranded radical is, if I just multiply both the top and the bottom, if it's a square root, it's easy. I just multiply by the square root, because what is the square root of something times itself? Just cancels the radical, right? So I just end up on the bottom with 7y. On the top, I've got my 2x cubed, and then I just have to multiply those square roots together. Well, the square root of 5x times the square root of 7y is the square root of 5 times 7 is 35, and then x times y, right? And that's it. How would I check it? Plug in a random value for x, random value for y. See if I get the same thing before and the same thing after on your calculator, right? See if you get the same decimal. Okay, what about this? This looks kind of complicated, but it's not that big a deal because it's just properties of exponents, right? With properties of exponents, if I divide like bases, what's my rule? Like if I had something, for example, like x to the 5th over x cubed, what's my answer? X squared, because 5 is bigger than 3, so I leave the base on the top and subtract the other one, right? Subtract the other exponent. So I get x squared. What if I had x cubed over x to the 7th? Where does it go? Where's the base stay this time? Bottom, because bottom's bigger, right? So I get 1 over x to the 7 minus 3, which is 1 over x to the 4th. Well, what's bigger here, 5/8 or 1/3? What's bigger? 5/8 is. How would I know? In this case, it's pretty obvious because 5/8 is bigger than 1/2, right? And 1/3 is smaller. But if I wasn't sure, I could just write them in terms of a common denominator, couldn't I? What's the least common denominator of 8 and 3? 24. So if I multiply, I'd have to multiply this one by 3 over 3 and this one by 8 over 8, right? And then what does that give me? So I end up with v to the 15/24 over v to the 8/24. And now it's obvious, 15/24 is bigger than 8/24, right? So we're going to keep the base on the top, and 15/24 minus 8/24 is how much? Seven 24ths. And 7/24 can't be reduced, so that's my answer, right? That's all you do, just subtract the fractions. Okay. This one, actually, this is very straightforward. It looks kind of weird, but it's no big deal. We're just going to distribute, right? If I distribute the square root of x, well, the square root of x times the square root of x is just x, right? Square root of x times -5 is minus 5 times the square root of x. If I distribute the -9, -9 times the square root of x is just that. -9 times the square root of x, and -9 times -5 is plus 45. So that's my answer. Does everybody see those are like terms? Right? I get -5 square roots of x plus -9 square roots of x, and so that's just -14 of them. So my final answer is just x minus 14 square roots of x plus 45. Okay? You good? Okay? Getting there. We're almost at the end. Okay, last few problems. These are the solving radical equations ones. These are really not very bad. People always are kind of scared about these because they're equations that involve radicals. But remember what our strategy is on these. All we're going to do is we're going to isolate the radical and take both sides to whatever power we need to undo the radical. On the final, it's all just square roots. So that makes it a little bit easier. If it's an odd root, you're done. If it's an even root, you got to check your solution. That's kind of the one weird thing about this that you got to always remember. So in this case, I already have my radical isolated, so I'm just going to square both sides. So the square root of x plus 20 squared equals 7 squared. What does that do on the left if I square a square root? Cancels it. Good. So I get x plus 20 equals what? 49. So what's x equal to? 29. Okay, I gotta check it though. So if I plug 29 back in, I get the square root of 29 plus 20 is equal to 7. Is that true?
Yeah.
That works, doesn't it? I get the square root of 49 equals 7. So yes, that checks. That's a valid solution. Okay. Okay, this one looks a lot harder, but it's not any harder at all. What do I do here? No, what do we have to do? We gotta undo the radical first. I just square both sides, but both radicals were already isolated, right? So if I just do this,
Oh, yeah.
it just undoes both
Can I run
radicals.
this to the office real quick?
Yeah, it's fine. So I get 4x plus 1 equals negative 6x plus 10. Solve it. So add 6x to both sides. Subtract 1 from both sides, and I get 10x equals 9. Right? And then what? Last step? Divide both sides by 10. And so I get x equals 9/10. Okay, that looks like a little harder one to check though, doesn't it? It's,
Why did you add 6x plus 1? Did you need to put a 10?
what did I do?
You added 6x plus 1.
Oh, no, I'm just adding 6x to both sides, because this is the original equation, right? See what I'm saying? And so I just added 6x to cancel the x's from the right and push them over to the left.
Oh.
See what I'm saying? So that's a harder one to check, but what we could do is just plug it in to a calculator, right? Non-graphing calculator, but calculators are fine. So look what happens. If I put in 4 times, well, x is just 9/10, isn't it? Whenever here's one hint though that's really helpful when you're checking answers this way. Whenever you're dealing with a fraction, you're checking an answer that has a fraction in it, always just put fractions in parentheses, and then you don't have to worry about order of operations. Then your calculator just thinks of it as a number, thinks of it like a decimal, right? So I've got 4 times 9/10 plus 1 under a radical, so the square root of all that gives me this decimal. If I plug in 9/10 over here, I get negative 6 times 9/10 in parentheses plus 10. I get the same decimal, so it checks, right? So that one works. Okay, this guy right here, same kind of thing, right? I've got a radical that's isolated, so I'm just going to square both sides. Well, on this side, that's easy. It just cancels the radical, and I get 6x plus 37. Over here, I'd have to FOIL it out, right? Let's just use the pattern a plus b squared equals a squared plus 2ab plus b squared. You could just multiply x plus 5 times x plus 5. It works. This is quicker. So that's like my a and that's like my b. So I'm going to get a squared, which is x squared, plus 2 times a times b. So 2 times x times 5 is 10x plus 5 squared. Now I just solve that, right? If I subtract 6x and subtract 37 from both sides, so I keep the x squared positive, then I just get x squared plus 4x minus 12 equals 0. So that factors, right? I just got to find all the zeros. What's that factor into? What do we get? X. I'm going to get a plus and a minus, aren't I? Because they multiply to a negative. So there you go. It's going to be a positive 6 and a minus 2. So my solutions then would just be what? Negative 6 or positive 2. But I got to check them. So if we go back up and let me just do this. Okay, so I got to check them in that equation, right? So what if I plug in the negative 6? Do you see any problems right away? What's the right side going to be? Negative. Is that possible? Not possible, right? I can't get a square root equals something that's negative, for real numbers anyway. If I plug it in, if I plug in the negative 6, on the left side I would get the square root of That's gonna give me a negative 36 plus 37. What is that? 1. Square root of 1 equals negative 6 plus 5, negative 1. Is that true? Not, is it? So that one, gotta go. It's not valid. It's extraneous. What about this guy? If I plug in 2, I'd get the square root of 6 times 2 is 12 plus 37. 49 equals 2 plus 5 is 7. Is that true? Yeah, it is true. Okay, that one works. So it checks, and my only solution is just 2 in that case. Okay? Last one. And then we're done. So this guy, this one looks terrible, and it could be, but it doesn't work out to be that bad, I promise you. This is one where, unfortunately, I can't isolate both radicals at the same time. I can only isolate one. Well, I isolated this one. So if I square both sides, I can only get rid of one radical at a time. So on this side, that's great. It works out to be just plain old, the radical and the squared cancel, and I just get x plus 12. But on the other side, it's not so good. This is like a, and that's like b, and I've got a plus b squared. Right, so what's that going to give me? If I square that out, square root, let's do it this way. I'll multiply it by itself this time, because that's the same thing as squaring, right? So if I distribute square root of x plus 5 times the square root of x plus 5, it's just x plus 5. Square root of x plus 5 times 1 is the square root of x plus 5. 1 times the square root of x plus 5 is square root of x plus 5, and 1 times 1 is 1. Well, those two are like terms. If I had x plus x, what would that simplify to? It'd be 2x, wouldn't it? So in this case, I've got square root plus square root is just 2 times that square root. So we end up over here with x plus 5 plus 2 times the square root of x plus 5 plus 1. So I can combine some like terms over here. I get x plus 5 plus 1 is x plus 6 plus 2 times the square root of x plus 5 equals x plus 12. But something great happens. What cancels?
How did you get 6 instead of 5?
5 plus 1
Oh, there.
is 6, right? So those two combine to give me a 6. So yeah, if the x's cancel, I can subtract x from both sides, right? And then let's go ahead and subtract 6 from both sides, and I get 2 times the square root equals 6, right? Well, now what? I gotta isolate x. What do? Divide by 2. So we get square root x plus 5 equals 3. Now what? Square it. And that gives me x plus 5 equals, yeah, good, subtract 5, so x equals 4. Plug it in and see. Does it work? If I plug in 4, let's see what we get. If I plug in 4, I'm going to get the square root of 9 is what? What is it again? Plus 1. So I get 4 on that side. Over here I get the square root of 4 plus 12 is 16. I get 4 equals 4, so it works. Okay? That one's supposed to be this amazingly hard challenge problem, but it's not that big a deal. You can do it. All right. The practice test is up. Look that over all week next week. All you got to do is just finish stuff up. That's it.